Well, good morning, everyone. My name is Max Lemme. I'm a co-organizer of this first edition of the International Conference on Neuromorphic Computing and Engineering here in Aachen. It's a pleasure to see so many people here this morning. And I will chair the first session. And we will start with important greetings from people in the Aachen region who are part of our ecosystem of research and innovation. And the first person to speak, and please give a warm welcome to Mrs. Sibylle Keupen. She's the Lord Mayor of the city of Aachen. Ms. Keupen, please.
Thank you very much, and warm welcome, good morning here in Aachen. And I'm happy to see a lot of young people here. Normally with the engineers, we see a lot of dark blue suites. Now it's a wonderful, colorful auditorium. Ladies and gentlemen, it's a great pleasure to say welcome to you, and it's a great pleasure to be here with Peter Janssens from the Forschungszentrum Jülich, and I'm really proud about to say welcome to the outstanding event, the coordinator, Professor Rainer Waser. Hello, nice to meet you. And Professor Max Lemme, who is guiding us through the conference. Ladies and gentlemen, our city unites tradition and modernity in a unique way. Aachen is a city of Charlemagne, is a home to a rich heritage that is reflected in its beautiful historical buildings and monuments, but also in cultural events such as the Charlemagne Prize. So in this May, we were able to award the Charlemagne Prize to the Chief Rabbi Pinchas Goldschmidt and the Jewish communities in Europe. And last year, we were very proud to award the Ukrainian President Volodymyr Zelensky and the Ukrainian people. Politicians from all over Europe come to Aachen to discuss about the future of Europe. But Aachen, as I have already mentioned, is not only rich in history and culture treasures, but also center of innovation and science. Aachen University is one of the most important technical universities in Germany and has a big influence of our city. Also with the four other big universities and the Forschungszentrum Jülich in our region, which give us a very big effort for research and education. The university attracts talent students and researchers from all over the world who work together here on the challenges of tomorrow. Aachen University contributes to innovation and technology, development in the region through its research projects and collaborations with industries. Aachen's close connection between the university and the city shapes the city shape and makes it as a center of science and education. Over the past years, Aachen has developed into one of the strongest and most beautiful startup locations in Germany. Young founders are looking forward companies with a brave spirit and an innovation strength. This dynamic startup culture is not only contributes to the economic development of our city, but also inspires many new ways of thinking and approaches. As well as history and science, there is a third aspect that makes Aachen special. Embedded in the Origio, Belgium, Netherlands, and Germany, we have close relationships with our neighbors and are proud to be part of a very good cross-border network. This can be seen, for example, in the Avantis European Science and Business Park. Avantis is a cross-border business park in the communities of Herlen in the Netherlands and Aachen in Germany. And it's now the home of many spin-offs from the Aachen University. You see, knowledge is growing and developing in Aachen. To bring this knowledge together, the city of Aachen created the Future Lab brand. What's this? The Future Lab brand is a project brings together the activities of the 5 universities in Aachen, and every year the Future Lab offers about 500 free projects and events on the topics of science and future. But there is also another very interesting thing in Aachen. 30 years Uni im Rathaus, which means university in the town hall, has been held twice a year, bringing together Aachen experts from science and society to discuss important questions about our future. So what can I give you more for your time in Aachen? The conference is a unique opportunity to combine the forces and perspectives for our research disciplines: neuroscience, electrical engineering, information technology, and computer science and artificial intelligence research. Take advantage of the opportunity for collaboration across disciplines, as this is essential to tackle the challenge of the time and our future, and develop sustainable solutions for us. And take the opportunity, if you have the time, to explore our beautiful city. This can also be done wonderfully on an after-conference drink in our beautiful old town. Thank you very much for your attention and a warm welcome to our wonderful Aachen city.
Thank you very much, Mrs. Keupen. By the way, thank you for coming to our conference, and those of us going to the conference dinner will visit our Lord Mayor in her workplace, namely the town hall, tomorrow evening. So we will come and visit you tomorrow night. The next speaker is Peter Janssens. Professor Janssens is a member of the board of the Forschungszentrum Jülich. The Forschungszentrum Jülich is one of our main sponsors for this event, so thank you for that. And also, of course, a key player in the Aachen region of research and science. No Scientology. No worries. This is about science.
Dear Lord Mayor, Mrs. Keupen, thank you for your personal and warm welcome here in Aachen. And have a good day, because you have other activities to look after. Thank you very much for joining us. Dear Rector Professor Rüdiger, virtually attending. Dear Honorary Chair, Professor Indiveri. Dear colleagues of RWTH Aachen University and Forschungszentrum Jülich. Dear conference participants, scientists and students. Also, on behalf of my colleague, Professor Astrid Lambrecht, Chair of the Board of Directors of Forschungszentrum Jülich, it's my pleasure to welcome you at the International Conference on Neuromorphic Computing and Engineering, ICNCE 2024. We are all aware that it's not if or when artificial intelligence will profoundly change the way we work. In research and science, in industry and services, as well as in our everyday lives. The question is rather how. A decisive boundary condition for this how will be the energy utilization associated with the use and development of AI. Training a large AI model, such as the one used in ChatGPT, requires several hundreds of megawatt hours of power. This is precisely where neuromorphic computing comes in. Neuromorphic systems are modeled by the way the brain works, promise to solve such AI processes more efficiently by several orders of magnitude than is possible with conventional digital computing. Here we can be inspired by nature, learn from the brain. Despite of its immense power, the human brain consumes only about 20 watts, which is similar to a relatively small light bulb. This efficiency is achieved, amongst others, by storing and processing information in the same place, known as computing in memory. In neuromorphic computing, this is made possible by new types of components, the so-called memristors. This new technology is a key innovation. In addition to computing in memory, neuromorphic computers offer also a high degree of parallel information processing inherent to their architecture. This not only further increases energy efficiency, this parallelism also has a positive effect in the context of AI development. The potential applications of neuromorphic computer range all the way from intelligent implants in medicine and pattern recognition in smartphones and automobile devices to the use of AI in industry, in agriculture, as well as in autonomous driving. At Forschungszentrum Jülich, expertise in neuromorphic computing is interdisciplinary and closely interwoven with computational neuroscience and an excellent infrastructure and expertise in high-performance computing. The Jülich Neuromorphic Computer Alliance, JUNCA in short, bundles these activities, connects researchers at important interfaces, and leaves room for growth with neural networks, which brings a real increase in efficiency. In the near future, our research infrastructure and expertise on site will be further strengthened thanks to the installation of Jupiter, the first European exascale computer. Jupiter will give the Forschungszentrum Jülich and its partners a pioneering role when it comes to AI applications and simulations, which in turn are of crucial importance in the development of neuromorphic hardware. Together with our strategic partner, the RWTH Aachen University, regional companies, and the research and development power that is bundled in the Aachen, Bonn, Cologne, Düsseldorf region, we have a real locational advantage to establish the technological basis for neuro-inspired AI hardware from Europe and contribute to German and European technological sovereignty. An innovation ecosystem for neuromorphic computing is emerging here in the greater Aachen-Jülich area. And this innovation ecosystem is also being created through networking, through collaboration between researchers in Aachen and Jülich with high-tech companies and startups based in the region. Our aim is to establish an international center for neuromorphic computing here, from hardware to software. I would like to take this opportunity to thank the Federal Ministry for Education and Research, BMBF, once again for funding the Neurotech project and the NeuroSys Future Cluster. The strong support from the federal government, as well as from the state of North Rhine-Westphalia for our structural change region, enables us, together with our partners, to create sustainable new value change and high-quality jobs through joint research, innovation and demonstration projects. Both Neurotech and NeuroSys aim not only to conduct excellent basic research into neuromorphic computing and AI, but they also transfer the expertise and technologies into our region. And thereby we actively pursue value creation with companies and startups based in the region. Together, we are creating sustainable jobs in the Rhineland region, in chip production, but also in plant engineering, measurement technology, and software development. The region may thus become a center of gravity for innovative companies in semiconductor industry, as well as in many AI user industries. Ladies and gentlemen, also on behalf of FZJ, I wish you all an inspiring ICNCE 2024 with challenging keynote lectures and exciting scientific presentations. And with that, I want to hand over virtually to Professor Rüdiger. Thank you for your attention.
Thank you, Professor Janssens. And now the last speaker to introduce and welcome you is our rector of RWTH Aachen University, Professor Ulrich Rüdiger. He is on a business-related travel this week, so he cannot be here in person, but he has sent us his greetings as video, which I hope we can now play here on the screen. So please go ahead.
Dear Lord Mayor, Ms. Kuipen, dear Professor Janssens, dear Professor Lemme, dear Professor Waser, ladies and gentlemen. As rector of RWTH Aachen University, it is a great pleasure for me to welcome you to the International Conference on Neuromorphic Computing and Engineering ICNCE 2024, the International Conference of the BMBF Joint Project Neurotech and the NeuroSys Cluster for Future. I would like to express my sincere thanks to the organizers of this event. Conferences like these are catalysts for new ideas, new collaborations, and the expansion of our own network. The subtitle, Knowledge Impact Networks, of our excellent strategy concept conveys that we at RWTH Aachen know how important interdisciplinarity and networks are. We have to look at scientific issues from different perspectives in order to obtain holistic answers to questions about global megatrends. The NeuroSys Cluster for Future and the Structural Change Project Neurotech are two large projects of our university in collaboration with Forschungszentrum Jülich and the Johannes Rau Research Institute AMO. In both projects, we work with highly interdisciplinary teams with broad transdisciplinary expertise of physicists, material scientists, neuroscientists, engineers, and computer scientists who cover most technical issues and create innovations together with economists. At the same time, ethics and sociology experts seek a link to society and politics. The vision of the NeuroSys Cluster for Future is to develop innovative hardware for artificial intelligence applications and establish the region of Aachen as a global leader in this field. In addition to that, the BMBF Joint Project Neurotech is inspired by the natural functioning of the brain to develop neuromorphic algorithms and architectures for innovative AI chips. The results of both projects will ultimately be used to build new innovation and value chains. The anchoring of holistic value creation, starting with cutting-edge research in the basic area and extending to applications and socio-economic aspects, is crucial here. At the same time, an attempt should be made to create technological sovereignty in Germany and Europe to safeguard European values and, in a further step, to develop recommendations for action for society and politics. I very much welcome conferences like ICNCE 2024 as an opportunity to build new interdisciplinary collaboration. Thank you all for your work on this important issue. I wish you many new and positive insights and an enriching exchange during this conference, with stimulating content, lively discussions, and the opportunity to expand your network. Thank you.
We will tell Professor Rüdiger about the applause. And now it's a great pleasure for me to introduce my colleague Rainer Waser. I was a student here at RWTH Aachen University in the 90s, and Rainer Waser was one of my professors then, and his course on electronic materials was part of the reason, a big reason why I went into microelectronics later on. And now I'm very humbled to be here to announce Rainer Waser as a co-organizer and, frankly, the main organizer of this conference. And Rainer, I really look forward to your introductory talk. Welcome.
Thanks a lot. Okay, Max, thanks a lot for this nice introduction. Lord Mayor Kuipen, dear representative of the Board of Directors of the Research Center Jülich, Professor Janssens, and in absence, dear Rector of our university, Professor Rüdiger. Dear Max, dear Bastian, dear Markus, dear colleagues, ladies and gentlemen, I would like to welcome you to this very special conference. Now, first, I would like to say a few words about the organization. You find more details on the leaflet, which you should have received at the registration. Posters are on the upper floor. Please vote for the poster award by Wednesday afternoon. The awards will be announced by Max Lemme in his farewell speech on Thursday. Then, of course, I would like to thank my co-chairs, Markus Diesmann, Bastian Leiber, and Max Lemme, and the organization team, which you see here. I don't want to go through all of them, which have been provided by several institutes. They and many more people in the background have been involved in all technical details that are needed in organizing such a conference. I'm very grateful to all of you. And of course, I would like to thank our sponsors, the gold sponsor Extron, the silver sponsor Exact Systems, and our 3 bronze sponsors, as well as our exhibitors. And I hope you take the chance to visit the stands of these exhibitors in the breaks. Let's step right into our motivation. One big problem of our time is the demand for electrical energy due to information technology. Here we've got the data of the Semiconductor Research Corporation 2015 with an update of 2021. You can see if you extrapolate on this log time scale here, if you extrapolate that around 2045, the entire generated electrical energy of the world will just be consumed by ICT. Of course, this cannot be the case, obviously, and will not happen, but it shows the enormous need for action. You can see that the increase is slightly slowing down. This is due to an increase or a growing portion of GPUs, which are a little bit more energy efficient than CPUs, but still a lot needs to be done. Unfortunately, still today, a huge portion of electrical energy is generated by burning fossil fuels. These are the data of the last 150 years based on various sources compiled by NASA. I know that there are strong personalities and groups in the political arena in Germany, in the US, and elsewhere who still deny the devastating effects of the increase of man-made CO2 on the climate. Those people simply deny scientific findings. The psychological problem is that long-term catastrophic developments, which are overlaid by strong fluctuations, are easy to deny because they hardly enter into people's direct experience. Of course, you and I are aware of the problem of climate change and the contribution by IT. The problem and its possible solution can be illustrated very nicely by the following comparison. A supercomputer has only a fraction of the power of the human brain, but it consumes 10 to the 5 times more energy than a brain using simulations. Since the brain is also based on physical matter, we should in principle be able to make electronics a few orders of magnitude more energy efficient simply using similar physical principles than the brain. This is the approach of neuromorphic or bio-inspired computing. And it brings us to our project. We are using biological neurons as an inspiration for neuromorphic computing. Biological neurons store information in synapses, in the conductivity, in the weight of these synapses, which are the contact points between neurons. And please remember that there are 10,000 neurons per individual neuron. We try to emulate the synapses by so-called memoristive devices, elements which memorize their resistance, and we investigate two types of memoristive devices. If we zoom in, we have redox processes in metal oxides on a nanometer scale, which are triggered by the motion of ions in high electric field and lead to a significant but reversible change in the electrical resistance. Or we have the change between amorphous and crystalline phases in higher chalcogenides, which can also lead to reversible resistance changes. And this is the foundation of our project Neurotech, Neuro-Inspired Technologies of AI for Future Electronics. As mentioned already, it is a BMBF-funded project to support the structural change in the Rhineland region away from coal into new technologies. Let's have a look at the work packages of Neurotech. We have got 6 scientific work packages and 4 cooperation projects with local industries linked to them. The first work package deals with various deposition techniques and a range of materials from transition metal oxides via 2D materials to phase change materials. Extron as well as surface science and technologies are involved in cooperation projects in this. The second work package covers the integration of these materials into devices, 2D and also 3D integration. The third work package comprises multi-scale modeling from atomistic simulation via finite element modeling to circuit simulation. The fourth work package deals with electrical testing of single devices up to entire arrays and circuits in cooperation with exact systems. The fifth work package investigates various neuromorphic circuit concepts in cooperation with Amotronics to develop the evaluation board for this. And the sixth work package looks into hard software integration of systems which evolve from these preceding packages. As you can see, Neurotech establishes a value chain, a horizontal value chain in the basic technologies of neuromorphic computing. This is just one recent result in which we demonstrate the co-integration of memoristic devices into or onto the CMOS platform. Starting from our chip design, we get the CMOS platform, the CMOS background fabricated by an external foundry. We will get the chips then back. We deposit our memoristic materials. We structure them into devices and circuits. And finally, we test them electrically for their function. There are several institutes and companies involved in this work. Those of you who are part of the Neurotech project will see more details in our General Assembly and midterm evaluation or midterm meeting on Wednesday, organized by Alexander Krüger and Caroline Wintel. And all others who are not part of the Neurotech project are invited to visit the Neurotech stand in the foyer. An even bigger endeavor is NeuroSys, neuromorphic hardware for autonomous artificial intelligence systems, coordinated by our session chair, Max Lemmer. It is a BMBF-funded cluster for future, so it is a cluster of projects. This picture shows how NeuroSys is going beyond Neurotech. In the Materials and Devices Foundation, there are also optoelectronic and photonic approaches. If we go up to circuits, architectures, and systems, then we also include pure silicon-based energy-efficient concepts such as FPGA concepts. And it proceeds into algorithms, applications, and the socio-economic impact and ethics. So the EuroSys cluster covers the entire value chain in a vertical direction. Consequently, EuroSys has got even more institutes and regional companies as project partners in science, in industry, and in society, and a large number of members in the advisory board, also going beyond our region, especially big industrial partners. Our application areas cover personalized care, healthcare, autonomous driving, smart cities, Work 4.0, and the Internet of Things, feeding into our vision that neuromorphic hardware is becoming essential for AI applications, that we are striving for trustworthy and resource-saving AI hardware. We want to implement European values in AI, and we foster the technology transfer to regional, national, and European companies. And that takes me to some highlights in science for both EuroSys and Neurotech. First, we are involved in an international project, NeuroBench, which aims at the development of a collaborative, fair, and representative benchmarking for neuromorphic computing. Then there has been a report in Advanced Electronic Materials about physical methods to study memoristic devices. And we have been contributing to the Springer Journal of AI and Ethics on sustainable AI. Furthermore, we strongly contributed to the 2022 roadmap on neuromorphic computing and engineering in the IOP journal of the same name. Although there are no official proceedings of this conference, the authors are encouraged to submit their conference papers to this journal. And finally, there is a new Springer book on the technological, economic, societal, and environmental dimensions of the transformation, which is covered in the EuroSys Cluster for Future. It recently came out on the market. This takes me to the highlights with respect to recent investments in the region. The Heraeus Group became strategic partner of X-Scale Photonics. Clinomic successfully closed a financing round. Our gold sponsor, Extron SE, invests up to 100 million euro in their new innovation center in Herzogenrath. And Black Semiconductor was selected as an important project of common European interest and also received venture capital funding. In addition, recently, the Roofline AI GmbH has been founded and received VC financing. They aim at a software development kit for AI computing. So by now, you should perhaps understand why we wanted to bring together these very different disciplines with their communities into this conference. We really need to foster the exchange between our three overarching disciplines together with their various subdisciplines. Only some of them are listed here. These are neuroscience and brain research, from neurophysiology to computational neuroscience and network dynamics, inspiring electrical engineering and material physics, from memoristic devices, circuit design and architecture to neuromorphic hardware, which finally feeds into computer science and AI research with machine learning, vision, graphics, speech, language, to symbolic AI, and further on to neuromorphic software, where neuromorphic software is somehow linking to all three big disciplines. So if we consider this, then we are aware of the fact that the three big disciplines are not even enough. We have to take into account also psychology and philosophy. And this takes me to an old but still highly relevant question. The question is, can and will AI systems develop self-consciousness, consciousness of itself? Some philosophers oppose this. They refer to the Chinese room argument and say that AI may only simulate consciousness but not actually experience it. However, a counter-argument by other philosophers is, if AI perfectly behaves as if it is conscious, it should be considered as such. I personally must say I stick to the first view. If somebody perfectly simulates being sick, I still would not call him really sick. Okay, anyway, what is consciousness? Certainly it is a spectrum of properties ranging from the mirror experiment and the ego perspective of chimpanzees to philosophical thinking of humans discussed by numerous philosophers and neuroscientists. The discussion if AI can and will develop self-consciousness was heated up very recently by Elon Musk, who said that AI will be smarter than humans next year. As you can imagine, Musk immediately faced opposition, for example, by Yann LeCun of Meta, stating that large language models will never reach human-level intelligence. And several people even started to bet against Elon Musk. And this topic certainly will be somehow touched upon during this conference as well. And with that, I would like to come to the end of my introduction. Let me finish by saying that the AI asked me to post this again. Do you already use artificial intelligence in your company? Between you and me, we don't even use natural intelligence. And with this little humorous interlude, I would like to thank you for your attention, wish you an interesting and pleasant conference, many new contacts, and a lot of insights. Thanks.
Thank you, Rainer, for this wonderful introduction. I think it's safe to say that we wouldn't be here today if it weren't for your great work here in Aachen over the last 30 years. And so thank you for that too.
Thanks.
Thanks, Rainer Waser.